So let's take a look at example 1. In example 1, we are supposed to find the equation of a tangent line for a given function at a certain point. So this is how the question for most of tangents and normals kind of examination question that you will be facing. So let's dive into this question. So you are given y is equal to x minus 2 multiply with x squared plus 1. So there's two ways on how we can go and differentiate this. Firstly, by looking at this simply, if you have a factor multiply with another factor, so you can directly say, oh okay, we can use product rule to differentiate this. But in a very easy case where it's a very simple functions like this, we can simply expand it first to obtain x cubed minus 2x squared plus x minus 2, and this can be differentiated by using sum or difference rule, so that will be much easier, right? So let's try differentiating this one, because we would like to obtain the function of gradient of tangent. So let's write it down. Function of gradient of tangent. This is how normally we call dy dx in differentiation, right? So dy dx is equal to, we are going to differentiate this one directly over here. So most cases we find the students copying this y back in here. So if you would like to copy back this x cubed minus 2x plus x minus 2, then you have to write ddx first in the front, because if you simply copy this one here and then suddenly you differentiate it later here without putting the operation, sometimes you will get confused yourself. But in mathematics sense, it is wrong. So it's better for you to, this one is dy dx, meaning to say we are ddxing the y. So now you can copy x cubed minus 2x squared plus x minus 2 into here, and x cubed will become 3x squared minus 2x squared become 4x, and x just simply becomes 1. So minus 2 is self-explanatory. Okay, so now that we have, this is the dy dx. So we have a given point which is -1 and -6. So the point given is -1, -6. Okay, so this point is actually xt, and this is going to be our yt. So now that we have everything, we can use the xt to find the slope. It's actually the gradient of the tangent line itself. So I'm going to use the word slope over here because it's more familiar for you. So slope of which is the m. Okay, so the m is going to be 3 -1 square minus 4 -1 and plus 1. So now our m value will be 8. As we have mentioned before, it's always good to put t over here so that we know it's a slope of the tangent line. In the later part, we're going to use m and a big capital N over here to signify the slope of a normal line, so it's very easy to be distinguished between each other. Okay, so let's cut to the end part of this example. Equation of tangent is going to be very simple. Okay, so simply use y minus yt equals to mt x minus xt. You have everything, right? So yt is a negative 6, so write it like this. It's going to be 8x minus with negative 1. I'm going to simplify it here, and then from all this it can be simplified into y equivalent to 8x plus 2, and that is what we are looking for from this example.